Okay, good morning, students. I request you to come online. In the morning, I got so many issues with my internet connection as well as with my Facebook Live. Ultimately, I'm able to make it now. So, quickly, we'll discuss the concepts where we left in our last class. We start from there and we'll discuss the concepts. So, yeah, in my last class, I started the concept of structures. So, from there only, we'll continue. So quickly, I will go to that point. I request you to post the attendance in the comment section. Those who are watching this video, and inshallah, we'll try to wind up this structures concept in this class. So this recursion and the related concepts we discussed in last class, along with the brief introduction about these structures we have done in my last class, isn't it? So a structure, as I said, it is a collection of heterogeneous data elements. Unlike your array, where an array is a collection of uh, homogeneous data elements, but we said a structure, it is a collection of heterogeneous data elements. Okay, so heterogeneous means what? Elements of different types. As you can see, I have written the meaning over here. Heterogeneous in the sense elements of different types. Okay, so probably if you see this diagram over here, so I declared, I mean, if we consider this as a structure, this entire thing as a structure, then this name, as you know, it must be of type character array. It is a string basically. Then ID will declare it as integer. Then marks you can put double or float. Basically, in terms of decimal points, also sometimes we get the average or sometimes we get the marks. Okay, so we better take these marks as float. So this is your character and this is your integer, and the last one, this is your float or double. So in that way, we can mix up these different types of data elements into a single entity, and that entity is nothing but your structure. We call this student as structure. Clear? Not only student. If you want to declare a structure for employee, you can do the same. Okay. In our further concepts, basically we do that one only. We declare different structures for students as well as for employees, and we see how these things can be manipulated and how these things can be used in our programming. Okay, so quickly, this is I have explained in yesterday's class. When we declare a simple structure, we can have any number of variables of that structure type. So as you can see over here, when I declare a structure of type student, which I have done in the previous slide, if you declare a structure of type this student, then using that student, you can create any number of variables. Here I have created 3 different variables of type structure. So where my structure is having these 3 fields into it, if I declare a variable of that type, that variable will also have that 3 fields into it. Okay, every field will store its respective data. Okay, if you want to go for prayer or if you want to have some other work, you can do that, but don't forget that the video will be saved here in this live session. I mean, here in this group only I am saving this live session, so you can watch it afterwards as well. Okay, don't post any comments that sir, we have prayer, stop the class, like that. Okay, I will continue with the class, I will complete my class. Whenever you have the free time, you just come and you watch this video. Okay, so quickly we'll discuss these concepts. So a single structure, we can have number of variables where every variable is going to have all the fields whatever you have declared inside that structure. So in my structure student, I have declared 3 fields. One is with name, the other one is ID, and the other one is marks. So when I create a variable of type that structure student1, so this student1 internally is going to have these 3 fields. So in those three fields, I can store the suitable data. So as I have done over here, I stored this name. Okay, this name into this name field. The ID 101 into this ID field, then marks 79.0 into this marks field. In that way, you can store your values inside structure fields. Every element, whatever you are declaring inside the structure, will be called like a field, isn't it? So here you can read that statement. Each element in a structure is called a field. A field is the smallest element of named data that has a specific meaning. So inside this name, you can store the name of that student. Inside this ID, you can store the ID of that student. Inside this marks, you can store the marks of that student. So these names and these fields, they are having some specific meaning inside your programming. Just give me a minute. Okay. So yeah, the difference between array and structure, as I said, an array will have only the elements of same data type. Array is a collection of elements of same data type. But whereas a structure, it is a collection of elements of different data type. Okay. Likewise, you remember, and we have seen that every entity, every element, and every what we call object in your C programming, before its usage, we have to do three things: the declaration, the definition, and initialization. Okay, we have to declare that entity, we have to define that entity, and we have to initialize this entity. So for declaration, what I said, in order to declare a structure as an element, it has to be declared, it has to be defined, and it has to be what we call initialized. So for declaring a structure, we have two different types, isn't it? The tagged structures and type defined structures. Yeah, we can use any of these two ways to declare a structure. A tagged structure, how we can do the declaration, that I have shown over here. Okay, we use the keyword struct followed by the tag. This tag is nothing but your structure name. Okay, your structure name you have to give over here. In place of the tag, you have to place your structure name, and all the fields, whatever you want to take inside the structure, those fields must come between these two curly brackets, opening curly bracket and closing curly bracket. Between these two curly brackets only, you have to put the fields, all the fields. Clear? So here this is a syntax for using a tagged structure, and here I have given the example. So I use the keyword struct. Be careful, you have to use I don't think so. This, yeah, no need of using this S as capital. This must be a small letter here because it is a mistake. It is an error of auto capitalization inside your PowerPoint or inside your Word. Whenever you are going to write the word, what will happen? It will automatically capitalize the first letter of the word. So because of that, you got the capital letter over here, and simply remember that this struct, it is a keyword. So as long as we are saying this struct as a keyword, and you know all keywords, they have only small letters, no capital letters are allowed in your keywords. So as you can see, a tagged structure start with a, you just read this statement. A tagged structure starts with a keyword struct. Over here I have not used any capital letters. Okay, why I got capital letters over here? In the sense, because of this auto capitalization feature. Okay, so here also you have to use all small letters only. Struct, all small letters you have to use. Struct followed by the tag of the structure, and all the fields you have to put between these curly brackets. Understood? So here, for example, I have taken a structure with name student. This is my tag to the structure. The name is student. Okay, this is structure name. Okay, inside this structure, I'm using how many fields? Three fields I'm using. One is character array, the second one is also character array, and the third one is integer. You can use anything. Just as an example, I have taken these three fields over here. Okay, so using this name, you can store the name of the student, you can store the ID of the students, and you can store the marks of the student. Okay, so always you have to remember, this is the note I have specified over here. You have to remember that the structure must end. The tagged structure or type defined structures, both these structures must end with a semicolon. The declarations, they have to end with a semicolon, unlike your functions, isn't it? So this thing you have to remember, that the structure declaration must end with a semicolon. So go to the next one. Yeah, this is type defined structure. The only difference over here is we are using this type def keyword extra. Okay, we are using this type def keyword extra. Okay, so rest of the things same, and previously we specified the tag. Okay, as you can see, the tag is specified over here, but now what we are doing in type defined structures, we are pushing this tag to the down. Okay, and we are using extra keyword type def over here, isn't it? That thing you have to remember. The difference between tagged and type defined structure is only this one. We are using in type defined structures, we are using one extra keyword, that is type def, and we are pushing this tag to the down. So as you can see, we are using this type def extra keyword, and we are pushing the tag to the down. Okay, over here we are calling it as type name. Clear? So in type defined structures, they are also similar to your tagged structures, but only one extra keyword type def we are using, and we are pushing the tag to the down. And like your tagged structures, here also type defined structures, the fields must be specified between these curly brackets, opening and closing curly brackets. So here is an example I have taken to that same structure, student structure. So as you can see, we are using two keywords to declare this type defined structure. The first keyword is type def, then struct, then curly brackets, and at the end we are specifying the type name. This is nothing but your type name. Okay, tag name. And what is the tag name? Student. And at the end we are using the semicolon as well. At the end, what we are using? We are using the semicolon as well. And all the fields we are specifying between these two curly brackets, opening and closing curly bracket. Between these two curly brackets only we are specifying all the fields, all our fields. So character array to store the name, to store the ID, then integer variable to store the marks. So quickly, yeah, this is the difference. Just now I have explained that one as well. The first difference is the extra keyword usage we are using. This is the difference between type defined and tagged structures. Okay, tagged structure and type defined structure, we are talking about the differences. There are two differences. The first one is we are using an extra keyword type def, isn't it? We are using an extra keyword type def. And the second difference is the identifier or the tag or the type we are specifying at the end of the block. We are not specifying at the beginning of the block, but at the end of the block we are specifying the type name, tag, or identifier, whatever you can say to that one. Okay, so go to the next one. Structure variable declaration. So this structure declaration, basically we are doing at global level, outside of the main function, before the main function, we can say. Structure declaration, where we are doing the declaration before the main function in the global declaration area. We call that area as global declaration area. Before the main function, whatever entities we are declaring, we call them as global entities. Okay, global declarations, whatever declarations we are doing before the main function, we call them as global declarations. Whatever declarations we are doing inside the main function, we call them as local declarations. Okay, in that way you remember global declarations, local declarations. Clear? So the structure, the declaration has to be done. For the structure, the declaration of a structure has to be done at the global area, but the variable declaration, structure variable declaration, has to be done in a local area, local declarations. So as you can see here, I have done the structure declaration at global level, global type declaration here I am saying. But when I am declaring the variables, I wrote here as local declarations. This is your structure variable declaration. And structure variable declaration, it is very simple. You have to remember, when you are declaring the structure variable and your structure is of type tagged, okay, your structure is tagged structure, then to do the declaration you have to use the keyword struct as well. Okay, when you are declaring the variable declaration, when you are declaring the variables, you have to use this keyword struct as well along with your structure name if your structure is of type tagged structure. But if your structure is of type defined structure, then no need to use that extra keyword struct keyword, no need to use. Simply what you have to do, use the structure name followed by the variable name. That's enough. Use the structure name followed by the variable name. That's enough. Quickly we'll see one simple example. This example on the output, on your what we call Dave CPP, your compiler. We'll see the example. So this is your compiler. So quickly what I have to do, I have to take one empty file. Okay, over here in this empty file, yeah, in this empty file, I will write that program so that you will understand how the structures can be used in our programming, and I will try to show the execution as well. Okay, so simple structure program. First, I will execute with only two fields. One is integer field and the other one is character field. Okay, so go to that Dev CPP. Here I am writing my program. How we can hash include stdio.h. So like a regular program only you have to start. So then I have to do the declaration at global level, isn't it? I have to do the declaration at global level. So this is my global declaration area. If I write int main of void, so then come over here. So whatever area we have after this preprocessor directive, after this hash include statement, and before this main function, we call this area as global area, global declaration. We call this as global declarations. Whatever declarations we do over here, they will remain global. Global means throughout the program you can use. Okay, so whatever declarations we do inside the main function, we call them as local declarations. Local declarations. These are my global declarations and these are my local declarations. So here I will do the structure declaration globally, because I have explained we have to do the structure declaration globally. That I am doing over here now. So how I can? So quickly I will use only type defined structures. Okay, no tagged structure uses. Okay, I will be using only type defined structures in all my structure programs. There are, even though there are two ways. Okay, even though there are two ways, we will discuss only type defined structures in our programming. Okay, let us remember that one. So we'll be using only type defined structures. So what is the syntax? How we can declare the type defined structures? First we have to use the keyword typedef. Typedef is a keyword followed by another keyword, struct keyword. Two keywords we'll be using. Then use the parenthesis to declare the structure. So here in this I'll be using my first variable a, okay, of type integer. My second variable character ch. So here, after closing the bracket, what we have to do? We have to put the structure name. So to make the difference between a regular variable and a structure variable, what we do? The structure name we take complete capital letters just to make the difference. Okay, just to have the difference, we will use all capital letters in our structure name. So this is my structure name, sample structure. Okay, so how I have declared this structure? First thing, I'm using the keyword typedef, then I'm using the keyword struct. Okay, this means I'm following the type defined structure. This is what type of declaration? Type defined structure declaration. So that also you remember, type defined structure declaration. Okay, type defined structure declaration I have done. So how? First the keyword type def, then the keyword struct, then opening bracket, then the fields. So as I said, a structure is a collection of elements of heterogeneous type, different types. So one element, as you can see, I have taken of type integer. The second element I have taken of type character. So a structure is a collection of heterogeneous type elements. Okay, and the name of the structure, the type, the tag. Okay, I have taken it as sample. Just to have the difference between your normal variables and structure name, normal identifiers and structure identifier, I used all capital letters in your structure identifier. Okay, so simply by seeing the name itself, you can tell that it is a structure identifier because I'm using all capital letters. Clear? So inside my program, yeah, in order to get the structure working inside my program, what I have to do? I have to create a variable for this sample. A variable for this sample. So it is nothing but it is a type definition. It is something like a type definition. When you declare a type, when you use this type def, you are declaring, you are creating a user defined type. So this integer, character, they are predefined types, and this sample, it is user defined type because you have created this type. So that is the reason why we are calling this sample as user defined type. So quickly go over here and create variables. See, if you have predefined types, you can create variables of that predefined type simply by specifying the type name and specifying the identifier. Here also sample is my user defined type. Now I want to create variables of type sample. How come? Simply put that sample over here. So all capitals. Sample followed by sam1 comma sam2. So now what will happen? I got two variables of sample type. The first one is sam1 and the second one is sam2, where these two variables, they are going to have their own fields. The sam1 is going to have ACH, sam2 is going to have ACH. Likewise, sam1 is consisting of these two fields and sam2 will also have these two fields. Whatever values you are going to store inside sam1, they are not going to affect sam2. In the same way, whatever values you are going to store inside SAM2, they are not going to affect SAM1. So quickly, how can we store the data inside these variables in the sense? So quickly, you see this one, SAM1, you have to use dot. SAM1 dot, when you put this dot, it will automatically show you what variables it is having into it. So inside SAM1, how many variables I have? I have two variables. One is A and the other one is CH. So first I am initializing A. It is an integer value, so I am keeping 20. Understood? So I am keeping 20. So then SAM1 dot, sorry, not SAMQ, SAM1 dot, now I'm initializing the character value. CH equals to, I'm keeping some A. Okay. So the next thing, SAM2 also I'm declaring SAM2 dot A, some 40 I'm keeping into it. So next thing, SAM2 dot CH. So over here into this, I'm keeping some B. B as a value I'm keeping. So now, if you see this one, internal to your program, internal to your memory, what will happen means, so we have created two structure variables of type sample. So I created sam1 comma sam2, like this I have done. Okay, so when you create a variables like this, variables of type sample structure like this, what will happen? Two different variables will be created. So inside sam1, what we will have? Inside sam1, I'll be having whatever variables you have declared inside that structure. Inside that structure, what variables I have declared? My structure name is sample. Inside sample, I have declared two variables. One is integer and the other one is character. So that same thing we will get over here. Clear? The same thing we will get over here. So this is your SAM1. So for SAM2 also you will get the same memory location. You will get the same memory location. This is your SAM2, SAM2. Clear? This is SAM1, this is SAM2. And what is this field name? This field name is A, which is of type integer, isn't it? So the field name is A. It is of type what? Of type integer. So better you put this SAM1 over here, SAM2 over here to the side. So this is your SAM1 and this is your SAM1. This is your SAM2. Okay, this is your SAM2 and this is A of type. Yeah, here also this is your A. This is what? CH character. This is CH. Clear? This is CH. So two independent entities. So this is of type integer and this is of type character. Here also same thing. This is of type integer and this is of type character. This is of type character. Two independent entities. So whatever content you want to store over here, how you can store? You have to use SAM because this particular block belongs to SAM1. So how can you access that one? SAM1 dot A. You have to use dot in order to access the particular field from a particular variable. Equals to what I said, I made it as 10. Then SAM1 dot ch, I made it as 8. So like this I have done. So internal to your program, what will happen? Internal to your memory, what will happen if you do like this? This 10 will be initialized to here. This 10 will be initialized to this block. Okay, and this 20, where it will come? Sorry, not 20. This A, where it will come? A will come to this point. A will come to this ch. Okay, character variable from SAM1 variable. Character field from SAM1. Character field from SAM1. Now, to initialize SAM2, what we do? Yes, use SAM2. SAM2 dot A equals to, I made it as like 20. Then SAM2 dot ch. SAM2 dot ch equals to, I made it as some B. Like this I have done. So in your program, what will happen? This will become 20 and this will become what? B. Like this. Like this it will happen. To access the members of a structure, what we are doing? To access the fields of a structure. So we call them as fields. Okay, this A, C, H, whatever we have declared, we call them as fields. Okay, so this SAM1, SAM2, we call them as variables of structure. Okay, structure variables. To access the fields using structure variables, what we are doing? We are using this dot, isn't it? We are using this dot operator. Okay, we are using this dot operator, or we can also call this as direct selection operator. Dot is nothing but direct selection operator. Understood? Direct selection operator, how it is helpful in order to access the fields from structure variables. In order to access the fields from structure variables, what we are doing? We are using direct selection operator. We are using direct selection operator. So in this way, you have to remember this program. Okay, understood? In this way, you have to remember this program. So simply to print the fields, yeah, so far what we have done, we have declared a structure in the global declaration area and we have created two variables of that structure in the local declaration area and we have initialized all the fields of all your structure variables. So structure variable 1, SAM1 is having two fields because we declared two fields inside that structure. SAM1 is having A and CH. That A and CH I have initialized. Then SAM2, it is also having A and CH. That A and CH I have initialized. So now in order to print those values, printf, okay, structure fields, FIELDS, structure fields from, okay, structure fields, that's it, you put like this, structure fields \n, close this one, then take another one, printf, okay, from sam1, from sam1 equals to, what are those? The first one is percentile d and the second one is percentile c, because it is a character. So how you can pass the values now? Okay, percentile d, that is nothing but sam1 dot a. So in this way only you have to pass. Then percentile c, sam1 dot ch. Okay, then you take here at the end semicolon, at the end semicolon. Okay, now, yeah, here you take one \n, yeah, here you remove this \n, here you take that \n, and same thing, print the values from sam2, printf, okay, \n from sam2 equals to percentile d, percentile c. Okay, how we can print? Again, sam1 dot a, comma, no, not sam1, this time sam2, because we are printing from sam2. Okay, sam2 dot a, comma, sam2 dot ch. So this will print all the fields from your structure, all the fields from your structure variables. These fields are from structure variable 1 and these fields are from structure variable 2. So quickly compile and execute the program to see the difference. Okay, I will save this program with today's date. Okay, test 4 of 4.c. Program is saved. Now go to compile, compilation successful. Yeah, go to execute, run. If you see the output, you will understand that one. Yeah, structure fields, as I'm printing over here, the same things I'm getting. First I printed structure fields message, that structure fields message I got over here. Then from sam1, okay, so here, okay, I have initialized 20 and 40, so that's why I got 20 and 40, but in your explanation I have taken over here 10 and 20, so I kept that 10 and 20 in the memory. Okay, just try to understand whatever values we will initialize, the same values you will get inside the memory as well. Clear? Hopefully you understood. So first we have initialized sam1.a to 20, it is an integer value, so using percentile d we are printing that value. Then sam1.ch we have initialized to a, so using percentile c we are printing, it is a character value. Then sam2.a we have initialized to 40, then sam2.ch we have initialized to b. Yeah, if you have any doubts you can post in the comment section. Yeah, quickly we'll do some more examples, okay, when we proceed in this topic. So this program I have done. How we can declare the structure? We have to declare the structure in the global declaration area. So as you can see, this is not the type defined structure, this is a tagged structure, because we took the tag at the beginning, as you can see, and there is no type def keyword, so it is a tagged structure. So in tagged structure, what I said, in the local declaration area, when you declare the variable, you have to use the keyword struct as well. But in our program, we used type defined structure. So here we used type defined structure. That's why my I'm using the keyword typedef as well. Typedef struct. Then I'm using the tag at the end of the declaration sample. Then yeah, when I declared the variables of my structure, I'm not using any special keyword over here. Just the structure name is enough. Sample, sam1, sam2. That's enough. No need to use any special keyword over here. Understood? Yeah, quickly we'll go to the PPT. Yeah, this one I have explained. Then, yeah, as you can see, you can initialize the structure fields by using the curly brackets as well. Instead of doing, instead of getting into instead of doing the individual initialization, you can do the initialization using these curly brackets as well. Okay, this is your simple initialization or basic initialization, we can say. This is your basic initialization of the structure, and this is your partial initialization. This is your partial initialization. There are two ways in which we can do the initialization. Okay, when you declare the structure variable. Okay, if you want to do the initialization where you declare the structure variable, we have two different ways. One is basic and the other one is partial initialization. Apart from these two, we have another initialization technique that we already seen. This technique using the dot operator. Using the dot operator also you can initialize the structure fields. This type of initialization we call it as individual initialization. What we call individual initialization. Individual initialization. So remember all these techniques. Three techniques basically we said. One is basic initialization, where we are going to initialize all the fields of your structure by simply using the set of curly brackets. This is basic initialization. In partial initialization, we initialize only few of your structure fields. We will not initialize all of your structure fields. This is partial initialization. And the third way is individual initialization with the help of direct selection operator. With the help of direct selection operator, we are initializing the structure fields. So three initialization techniques. This is your third way of initializing the structures. This is your first way of initializing the structures. This is your second way of initializing the structure. So quickly we'll see one simple program, yeah, for this all three possible techniques. So here, as I have declared, let us see how many, yeah, what fields I have. Int x, float t, character u. How many variables I have over here? How many fields I have inside this structure sample? I have four fields, two of type integer, one is float and one is character. The same fields I will take inside the structure sample. Int x, int y. So this is my int x, and then I am taking int y. Then I have float, I think over there, float t, character u, float, float t, then character u, and I am keeping my structure name as it is, sample. So over here inside the local declaration, what I am doing, I am taking three structures to explain three things. I am taking three structures. So second structure and third structure. Structure 3. So I will make the names like, this is basic. So bsam1. This is 1, 2, 3 not required. This is bsam, means basic initialization. This is partial, psam, partial initialization. This is individual initialization, isam, individual initialization. So for basic initialization, what I have to do here, only I have to initialize the stuff, isn't it? So I will quickly take the curly brackets and I initialize all these things. How many values I have to pass? I have to pass four values, two of type integer, one is float, and the last one is character. So pass that one. Okay, 5 comma the second integer, I'm passing 10. Then what I have to pass? The third value. Inside bsam, I'm going to get all these, isn't it? Because this bsam is of type sample. If bsam is of type sample, inside bsam, I'm going to get all these variables, all these fields. So first field I have initialized to 5, second field 10, t I will initialize to 12.24. 12.24, and the last field, which is character, so put that character as a only. Okay, so in this way we can do the initialization. This is basic initialization. Then do the partial initialization. Partial initialization in the sense, I will initialize the variables partially, I will not do the full initialization. So I will simply put some 50 comma 100. Only two values I am passing, but inside this structure variable, I'm having how many? Four fields. in 4 fields I'm initializing only 2, so rest of them they will remain uninitialized. So basically what you will get here default values. Inside T you will get 0, 0.0, and inside C you will get sorry, this is U, right, over there. So inside U you will get a null value. So as you can see in the slide, so over here, see, when you do the partial initialization, what I am saying, the first field, first value, whatever you initialize, that will go to the first field. The second value will go to the second field. And as I don't have any third and fourth value, they will become default values. So float value default value is 0, 0.0, and character value default value is null character. So in that way you will get those two values. They will not remain uninitialized, or they will not hold garbage values over here. Clear? They will not remain uninitialized, or they will not hold garbage values, rather they hold default values. And for float, what is the default value? 0, 0.0. And for character, what is the default value? Null character. For integer, what is the default value? 0 is the default value. So likewise, fields of your structure, when they are uninitialized, they will not remain, they will not hold garbage values, rather they will hold default values. The default values are nothing but, for real numbers, float and double, 0, 0.0. For integers, 7 and 0, only 0. For characters, null character. Likewise, all your fields will hold default values. Okay, so the next thing, inside your program, quickly go to your program and see. Yeah, this is partial initialization. So for this ISAM, what I have to do? I have to do the individual initialization. That individual initialization here I am doing. Quickly see. Individual initialization is nothing but using the dot operator, that is direct selection operator. ISAM dot x equals to some 120 I'm storing. ISAM dot y equals to some 125 I'm storing. Then the next one, ISAM dot float value, right, equals to some 3.175 something I'm storing. Okay, then ISAM dot u, that is character value, I'm storing after a z I'm storing. In full okay, in individual initialization I'm storing z. So here also you try to print all those fields. So first from, okay, from basic, this is basic. So how can I print? Basic is what? BSAM, isn't it? BSAM. How many values I have? 2 integer values. So 2 percentile D's, 1 float value, so percentile F, and 1 character value, so percentile C. So in this way we can access. So SAM1 dot, not SAM1 now, no more SAM1. This is BSAM1. BSAM dot A, not A, X. BSAM dot X, then bsam dot y, bsam dot y. So this is my second value I'm printing. So next, third value, bsam dot, what is that? T, isn't it? Float value is T only, right? Variable name is what? Field name is what? Of float, T. Okay, so T, that's it, T. Then what we have to print? The last value, that is bsam dot u, that is character value I am printing. So in this way we printed all the values. So same statement you copy, same statement, okay, then you print. So for second how we done the initialization? After basic we have done partial. So I took the variable name as psam, okay, psam, and the field names I'm going to follow this order only. First two integers, then float, then character. So here partial initialization. So psam dot x. Okay, here you have initialized this to, I think, 50. Okay, psam dot x will become 50. psam.y will become 100, but we have not done the initialization for psam float, so you will get 0.0 over here, and we have not done the initialization to this psam.u. There also you will get null. I don't think we can access this float values, but we will see. If you do this program, okay, accessing float members from a structure in your Turbo C, it will not support. Okay, Turbo C, you cannot access float values inside structure. So that will generate an error, but we will see what type of error we will get in this Dave CPP. It is a different compiler, Dave CPP. Maybe you will not get that error over here. We will see. So lastly, individual, isn't it? Individual initialization. Individual initialization I'm doing over here. So go percentile D, percentile D, percentile F, percentile C. We are printing these values. So individual initialization, what name I have given? ISAM, isn't it? ISAM.x. Next is ISAM.y. Okay, then ISAM.t and ISAM.u. So simply with the help of dot operator we are printing. With the help of direct selection operator we are printing. So this is basic initialization, this is partial initialization, this is individual initialization. These three ways, in these three techniques you can initialize the variables of, the fields of your structure. Quickly save this program. Already the name has been given. So go and compile. See, I'm not getting any errors. So then we will see run. Yeah, as you can see, I told you it is not printing. That null character we cannot print on the output screen. Null means nothing. I told you. Null means nothing. No representation. No character representation. Null means nothing. So that's why you're not getting any null character over here. So inside basic initialization, what we have done, quickly we'll go to the program and we will see inside basic initialization. See over here. I kept inside basic initialization, I kept 5, 10, 12.24 and 8. So from basic initialization, I am getting 5, 10, 12.24 and 8. Partial initialization, I kept what I kept inside that partial initialization. Yeah, this thing. Partial initialization 50 and 100. Okay, 50 and 100. But that T and U, float and character, I have not initialized. So for float, you are getting 0.000 default value. But for character, you are not getting any printed character over here, because null means nothing, no representation of character. It is not going to have any graphical symbol associated with it to print on the output screen. Null means simply nothing. So you will not get any character on the output screen. So then from in your programming to specify the null character, we use that / followed by 0. Isn't it? / followed by 0. But when you print that null character on the output screen, you will get nothing. Null means nothing. Okay. From individual initialization, this must be I over here, not BSAM. It must be A, because this is not basic initialization, it is individual initialization. So for individual initialization, what I have done, I have initialized all my variables, all my fields to 120, 125, 3.175 and Z, the same characters, the same field values I am getting on the output screen. So in that way, you can declare a structure declaration I have explained over here. Declare a structure in the global area. For defining the variables, you have to follow structure name followed by the variable name. This is defining the structures. And initialization, you have three different techniques: basic initialization, partial initialization, and individual initialization. You can follow any of these approaches to initialize your structure. Okay, so far we have seen how we can declare, how we can define, and how we can initialize. All three formats we have discussed. All three forms we discussed. All three important ways of using your structure we discussed. So this is also done. So accessing structures, how we can do? With the help of that direct selection operator. So here structure fields can be accessed and manipulated using an operator just like any other normal variables. To refer to a field in a structure, the structure and field both has to be referred. C uses hierarchical naming convention. Hierarchical naming convention in the sense first the structure name, then the field name. Structure name followed by the field name. In between, what you have to put? You have to put the dot operator. And that dot operator, okay, the structure variable identifier is separated from structure field by a dot. Okay, by a dot. This dot is known as direct selection operator. Just now I have explained this thing. Okay, how we refer the dot? We refer to the dot as direct selection operator. Inside your this presentation also, I mean inside this paint also I have explained this one, direct selection operator. Okay, simply remember this statement. Whenever we are accessing the structure fields, how we are accessing? We are accessing with the help of direct selection operator. This dot, whatever we are using in between these structure name and the field name. This is your structure name and this is your field name. Between the structure name and field name, what we are doing? We are using this dot operator. This dot operator is nothing but your direct selection operator. This dot operator is nothing but your direct selection operator. From here to here, you remember. We call this as direct selection operator. Clear? Hopefully you got the answer. Yeah, if you have any kinds of doubts, anything that you're not understanding, you can ask me at any time. You can post that message in the comment section so that I can answer. Okay, so quickly we'll go to the presentation once again. So all these things we discussed, how we can do the individual initialization, how we can do the basic initialization, and how we can do the partial initialization. Those things we discussed, and I have demonstrated that with the help of a program, isn't it? That only I have written program to demonstrate the structures. Okay, how we can do the declaration of a structure, how we can do the definition of a structure, and how we can do the initialization of a structure. So declaration, what we said, structure declaration we can do in two ways. The first one is tagged structure and the second one type defined structure. Tagged structure, how we can do? First we use the keyword struct, then followed by the structure tag, and then between the curly brackets we put all the fields belonging to a structure. Then at the end of the structure declaration we must have to use the semicolon. Then type defined structure, we use an extra keyword typedef along with that struct. So how the declaration will be? Typedef struct, between the curly brackets we put the fields, and at the end of the structure we specify the type name before closing that structure declaration. After specifying the type name, we use a semicolon at the end. In that way, we can declare a structure, a type defined structure. These two are the ways to use to declare a structure in your C program. So basically, where we do this structure declaration, we do the structure declaration in the global declaration area. And I have shown you where that global declaration area will come and where the local declarations will come. Everything I have explained. Global declarations, they will come before the main function, and local declarations, they will come inside the main function. Okay, this is about structure declaration. Structure definition, how what we said, if you are using tagged structure, in order to declare you, in order to define your variables, what you have to do? You have to use the keyword struct followed by the tag name followed by the variable names. But if you are using the type defined structure, no need of that struct keyword. Simply what you have to do, you have to put the structure name followed by the variable names. Okay, so last thing, structure initialization, what we have seen. Structure initialization, how we can do? We have three different ways to initialize a structure: basic initialization, partial initialization, and individual initialization. Basic initialization, simply with the help of curly brackets, set of curly brackets, we will pass all the suitable values. You don't have to leave any field uninitialized. What you have to do, you have to pass all the field values between the curly brackets, and at the end what we do, we put a semicolon. Clear? Then partial initialization, how we do? Simply you have to initialize only few of your fields. We will not initialize all the fields. We will initialize only few of your structure fields. Then it will become partial initialization. In case of partial initialization, if you left any field uninitialized and if it is an integer, okay, by default it will not hold garbage value, rather it will hold 0. If it is a float value, by default it will not hold garbage value, rather it will hold 0.0. If it is a character value, by default it will hold default value, not the garbage value. Default value in case of a character is null value, null character. That null character will be initialized to your character variable, character field. Okay, up to this we discussed. So program demonstration also I have shown. So then operations on structures. Okay, we can copy one structure to other structure simply by using the assignment operator. Okay, simply by using the assignment operator, you can copy one structure to other structure, where both these structures, there is a condition, both these structures must belong to the same structure declaration. Okay, both these structures must belong to the same structure declaration. So in case my program, I will quickly go to my program. Simply remember this one. Using the assignment operator, you can copy one structure to the other structure. Okay, using the assignment operator, we can copy one structure to the other structure. As you can see, before my initialization, before my assignment, this SAM1 is holding what? 2, 5, 3.2, 8. Same structure, what I have declared in my previous example. X, Y, X is of type integer, Y is of type integer, T is of type float, and U is of type character. So I have initialized 2, 5, 3.2 and 8. In my SAM2, they are holding 7, 3, 0, R. Clear? So after the initialization, after the copying like this, after the assignment operator between the two structure variables, what will happen? This entire structure will be copied over here. These entire field values will be copied over here. So here in your SAM2 will also hold the same field values as your SAM1 is holding after this assignment operation. Over here, what we are doing? We are performing an assignment operation between SAM2 and SAM1. That assignment operator will copy the fields, the field values of SAM1 into SAM2. That is the reason why before the initialization, SAM2 was holding different field values. But after the initialization, after this assignment, your SAM2 is also holding the same field values like your SAM1. As you can see the difference over here. So simply, practically also I will prove this mechanism. I will go to that program, or not this one. Yeah, this program. So over here, we have done the basic initialization for this BSAM. So now again, I am making this BSAM as SAM1. Okay. So then I am making this BSAM to SAM2. Just to resemble your program over, just to resemble your example over here, I am doing this kind of things. Okay. There is no other meaning. Okay. So here what I have to do? Simply I have to initialize more two variables. That is 3.175 something, and the last character I am initializing to Z. So like this I am doing, and all these things you just remove. Okay, so here printf before assignment, I am printing the values before assignment. Before assignment, that assignment, what it will do? Copying. Basically it will do the copying. So before assignment or before copying what values your structure variables are holding, that I will print over here. Okay, structure fields. So same thing, structure fields. So this is SAM1, what values it is holding, that I am printing. So again, all these values I have to change. All these names I have to change. Instead of bsam, I have to make it as sam1.x, then sam1.y. Okay, then sam1, sam1.t, and lastly sam1.u. So like this. So again, I have to print before assignment. I have to print SAM2 values as well. So my SAM2 will hold all these same two integers, one float and one character. So this is sam2.x. So remove this. Again sam2.y. Remove this. sam2.t. Remove this. sam2.u. Clear? And remove this individual initialization because we are not taking that into consideration. Okay. So then what we have to do? Yes, after the initialization, also after the assignment, after copying also we have to print those values. But before that, before printing that, I have to do that assignment, isn't it? sam1 equals to sam2 I am doing. So I am initializing whatever content we have inside sam2 to that sam1. So these content will be overwritten. These content will be overwritten with this content, with sam2 content. sam1 content will be overwritten with sam2 content. So next thing, here before, in place of before, I have to put after assignment. Here you use \n as well 2 times, so just to give the difference. So clear? So now after assignment, no changes, simply I am printing the same variable values. So go compile, compilation successful, then go and run. See that program over here, the output, what output I got. See, so before the assignment or copying structure fields, what values I have? Inside SAM1, I have these values 5, 10, 12.24 A. Inside SAM2, I have 50, 100, 3.175 Z. After the assignment, after the copying, that means in between these two, what I have done here, I kept SAM2 equals to SAM1. Like that, I kept over here, isn't it? Here I put SAM2 equals to SAM1. So after that assignment, what is happening? Your SAM1 content is copied into SAM2. So whatever SAM1 is holding, the same content SAM2 is also holding now. Clear? So I think we have done SAM1 equals to SAM2. So SAM2 content we are copying into SAM1. So there is the reason why you can see inside SAM2 we have this one. So after the copying, inside SAM1 as well as SAM2 you will get the same content over here. You can see. So this is using the simple assignment operator, we can copy one structure to other structure. Using the assignment operator between the arrays is not possible, but between the structures it is possible. You have to remember this statement. Between the arrays we cannot use. Why means? Because your array name will indicate the address of the first memory location. When I explained your pointers concept, the relationship between arrays and structures, there I have given this statement. You might have remembered. If you are not remembering, just go there and refer that concept. Okay, your array name will give the address of the first memory location. That is the reason why whenever we are seeing A, that A points to the first memory location. How can we point the second memory location? A plus 1, A plus 2, A plus 3, second, third, fourth location. Like that I told you. There are two ways to access the structure elements. One is with the help of indexing. The second one is with the help of pointer arithmetic. These things I have explained on that day. Maybe you are remembering or not, I don't know. So quickly you go to the yes operations on structure discussed. Yeah, the assignment operator, this program explanation just now I have given. See, same thing I have done. SAM1 I have initialized with these values. SAM2 I made it uninitialized. Then I'm copying SAM1 into SAM2. After copying, I'm printing both the contents, SAM1 as well as SAM2 contents. In both the places, I'm getting the same values because using the assignment operator, I copied the SAM1 values, field values into SAM2. That is the reason why I'm getting same values in both the places. Okay? So quickly we'll go to pointers to structures. Okay, pointers to structures. Instead of declaring a structure variable like a normal variable, we can declare a structure variable as a pointer variable. Okay, structure variable as a pointer variable. So then how we can access that structure pointer, pointer structure variable of its fields, in the sense you have to use these formats. So if this entire thing is your structure, if this entire thing is of your structure and your SAM's address you are storing into this PTR. Okay, this SAM1's address if you are storing into this PTR. So now using this PTR, how can you access this X, Y, T, U in the sense like this? PTR star ptr dot x will become your x field, star ptr dot y will become your y field from the sample structure, star ptr dot t will become your t field from your structure, and star ptr dot u will become your character field, that is u field from your structure sam1. So two ways to reference x when you have pointer associated with it. One, directly using the direct selection operator, that is dot operator you can use, or if you want to access that same field with the help of pointer, then you have to use star ptr dot x. Like this you have to use. Quickly I will do one simple example. Or see, using this is quite tedious, isn't it? Accessing simple sam1.x is very easy, but when you have the pointer to that structure, using the field, using the pointer is very difficult. Okay, accessing the field using the pointer is very difficult because you have to use indirection operator, clear, indirection operator, then pointer identifier, then two set of parentheses, then direct selection operator, then x. These many operators you have to use. But instead of going with this, we have a shortcut method to access the pointer fields, that is with the help of arrow operator. We call it as indirect selection operator. Over here you can see this arrow operator or indirection operator. Indirection or arrow operator. Okay, so this is not indirection operator, this is indirect selection operator. You remember like this. This is indirect selection operator. Indirection operator is your star operator only. Huh? So this is indirect selection operator. How we call it? Indirect selection operator. So instead of using that indirection operator followed by the parenthesis followed by the direct selection operator, what we do, we simply use this arrow, that is nothing but indirect selection operator. This is your indirection operator. So how can we use okay, what we have replaced? So suppose you have a structure variable sam1, you have a structure variable sam1. I will show you with the help of this paint, because over here the handwriting with mouse it is not coming properly. So whenever it is possible I am using MS Paint. So in this MS Paint I will explain that concept where we have to use that indirect selection operator. So quickly, we have the structure with name sample that we have already done inside your program. So using this sample structure I am declaring a variable sam1. So now I want a pointer to this sample. So if you want a pointer to integer, what you do? Int star you will put, isn't it? In order to declare a pointer of type integer, int star. But now I want to store the address of this sam1. This sam1 is of type what? Sample. So I have to declare a pointer of type sample. So quickly do that one. Sample star. That's it. Int star will declare a pointer of type integer. So sample star will declare a pointer of type sample. So that PTR I am saying. Okay, PTR. So now inside this PTR, I am storing the address of sam1. Address of sam1. Clear. Now PTR is holding the address of sam1. If you see this one over here, you will understand. Yeah, this is what happening. My sam1 is holding all these variables. My sam1 is holding all these fields, and this pointer is pointing to that sam1 because it is a pointer, and I saved the address of this sam1 inside this pointer, inside this PTR. So this PTR is pointing to that sam1. So quickly I will try to take that figure into my consideration. So okay, go to that. MS Paint. So over here, like this, we have. So by SAM1, it is having X, Y, T, U, and PTR is pointing to that SAM1. So now, in order to access this X, Y, T, U, using this SAM1, directly I can write how? Directly I can write SAM1 dot X, isn't it? SAM1 dot X, SAM2, not SAM2, SAM1 dot Y, okay, then SAM1 dot T, SAM1 dot U. In this way, I can access all the fields using this SAM1 variable. But the same fields, if I want to access with the help of this pointer, because pointer is an efficient way of accessing the fields or data members from a array, from a structure, from a normal variable, from wherever you are accessing. Pointers are the efficient way of accessing the memory locations. Okay. So next thing, if you are accessing that pointer, that field values, the structure field values with the help of this PTR, what I told you here I have shown how we have to access. Yes. So that is star PTR of dot X. Okay, then Y, how I can access? Star, okay, PTR dot Y. So like this, or star PTR dot after Y what we have? T. Okay, then star PTR dot U. In this way also you can access. This is using pointers. But using this star, that is nothing but indirection operator followed by the direct selection operator. How many operators we are using? Here we are using only one operator, that is direct selection. Direct selection. Direct selection operator. Here how many operators we are using? In this type of access, I'm using only one operator, that is direct selection operator. But in this type of selection, I'm using two operators. What are those? First is indirection, that is star operator. Indirection operator, and the second operator is direct selection operator. Direct select, names are quite confusing, but you have to remember these names. Direct selection operator, because with these names only we are going to narrate the answer. Okay, indirection operator, that is nothing but your star operator. We call that star operator as indirection operator. Then we are using dot also, direct selection operator. But over here we are using only one operator, that is dot operator. So if you have dot and star operators together, so instead of using those two operators, we can replace a single operator when you are using a pointer to access the structure fields. So how come? Simply use PTR arrow mark X. Okay, PTR arrow mark X, then PTR arrow mark Y, then PTR arrow mark, what is that? PTR arrow mark T. Finally, PTR arrow mark, here not 0, PTR arrow mark U. Like this, you can access all the elements of your structure when your structure variable is a pointer to the structure. So here, how many operators we are using? Here also we are using only one operator, that is direct selection operator. So in this way, you remember, whenever we are having only structure variable, here I got confused. It is not direct selection operator, it is indirect selection operator. We call this as, because with the help of pointer we are accessing the fields indirectly. So indirect selection operator. Clear? Like this you can do. So these things you have to remember. whatever I have dictated over here, whatever I have given over here, you have to remember. Okay, so I will make some statements after this. So see, accessing with the help of structure variable. The x variable, how we are accessing? With the help of structure variable. This is same like accessing the structure, field with the help of pointer. Accessing the structure field with the help of pointer like this, using indirection and direct selection operators. ptr dot x. This is also same like this is also same like this is also same like okay, accessing the structure variables using indirect selection operator. That is, indirect selection operator is nothing but ptr arrow of x. That's it. In these three ways you can access your structure fields. This is when the first one is when you have normal structure variable. Okay, this is normal structure variable. If you have a normal structure variable, directly using direct selection operator, you can access the fields. You can access the fields. This is when we use, when we have pointer to the structure fields. These two operators, these two ways, when, okay, when we have pointer to the structure variable. Structure variable. Understood? This is when we have pointer to the structure variables, we use this approach. If you have a normal structure variable, we use this approach. In this way, you can access your structure members or structure fields. Clear? So quickly we'll go and we will see a simple program. This program only I will try to modify. So SAM1 I have declared and initialized as well. So SAM2 I will simply remove this entire thing because I don't need these things. Only one structure is enough. Declared and defined, one structure is enough. So here how we are accessing. So after this we have to declare a structure pointer as well, isn't it? So that structure pointer, how can we declare? Sample star. Sample star. Okay. Sample star, what we have to do? Sample star PTR. Now this PTR will become my pointer. PTR is a pointer. So inside that PTR, I can store the address of SAM1. Clear? I'm storing the address of SAM1 inside this PTR. This PTR is of type sample. Okay, pointer variable to that sample structure. This SAM1 is a normal variable to this sample. So next thing, printf access using access using just wait a second. Just give me a second. Okay. Okay. So here access using, okay, this is my last program. I will post another video if possible in the evening. There I will explain the complex structures, and after that the files concept also I will post another video. So whenever it is possible for you to see, you just watch the videos and post your attendance. Okay. So access using structure, uh, access using structure variable, normal variable, isn't it? Access using structure variable. So how we can access structure fields? Like this only. Someone dot using the direct selection operator. So but if you are accessing the variables, here you put backslash n, and here another backslash n you put. So how we can access? Using pointers, access using structure, access using structure pointer. Okay, pointer, using pointer, how can we? I told you already, I'm storing the address inside PTR. So I told you how can we access. Instead of sam2.x, what we have to write over here, we have to open the bracket, star PTR, isn't it? Star PTR.x, because PTR is holding the address of structure. So star PTR will give the pointer, I mean structure reference over there, indirection address over there. Star PTR, remove this sam2 dot t. So lastly, here also how you can access star PTR of u. So like this you can access. Like this you can access all the fields from your structure. So next thing, using indirection. This is, see, access using structures, but how many operators we are using? Two operators. I am writing that one over here. Two operator method. Two operator. Two operators we are using. But here, how you can access the same thing? Access using structure pointer. Okay, using only one operator. How you can do? Using only one operator. Using only one operator, how you can do? Yeah, using only one operator. That one operator is nothing but your, see here, someone content only we are printing. Someone, here also someone. Remove this one. This one you remove, and here access using structure pointer, structure fields from someone. How we can access? So instead of using the dot and star, so I told you instead of using the dot and star, we can use the arrow as well. So we have done this one. Direct selection we have seen. Okay, indirect selection, indirection and direct selection we have seen. Two we have done already. So using arrow now. The third type is using the arrow operator. So that arrow operator between PTR and the field name we have to put. Remove this one. Arrow operator same. Hyphen followed by the less than symbol you have to use. Hyphen followed by less than symbol you have to use. So in that way you can access like this. PTR of, see, when you are typing that PTR of, it is automatically giving you that reference. Okay, so PTR of Y we are printing. Then third one, PTR arrow, PTR hyphen, okay, open, that is less than symbol, less than, greater than symbol, sorry, not less than, greater than symbol, PTR hyphen greater than symbol. So in this way, this is the third type of accessing your fields. One, using the direct selection operator when you have structure variable, using direct selection operator and indirection operator when you have pointer, and lastly using indirect selection operator when you have pointer. Okay, so quickly we'll go and we will see output. We have to get the same output in all the possible cases. In all possible ways, we are simply trying to access those members, isn't it? Those field values. So I should get all those values over here, same values over here. If you see the output, It is printing like that only. Access using the structure variable. Structure variable in the sense what operator we have used? Direct selection operator we have used. So 5, 10, 12, 8. Then using pointers, two operators we have used. What are those two operators? Indirection operator and direct selection operator. Star and dot, same values we are printing. Access using structure pointer, only one operator we are using. Okay, 5, 10, 12, 0.248, same values we got in all my places. So that means all these are different ways of accessing your structure elements, structure field values. Clear? So you have to understand this concept and you have to remember this concept. Okay, so after that, after these pointers to structures, yeah, I have shown you what does that star dot everything means and how you have to refer those star dot everything. I have shown you the arrow operator also. I have given explanation to you. Okay, so this is something. See, this also the three possible ways to refer a particular field from your structure. Okay, using sam1 dot x ptr. So this is indirection and direct selection operator, and this is using arrow operator. This entire thing I have explained. So the demonstration, program demonstration also I have given. So that's it. Okay, there is in our next class we are going to discuss about complex structures. That maybe today evening or tomorrow morning I will give that video. I will live stream that video. Be ready for that, man. Inshallah, by tomorrow evening, or we will be left with only files concept by tomorrow evening. Okay, after that, in one more class, I will try to wind up that files as well. With that, we can conclude your complete syllabus. Hopefully. Thank you very much, guys. Yeah, if you have any doubts, you can post in the comment section. Thank you very much.